Hello guys, what's going on? And welcome to my channel Logic Bytes by AK. Myself Anand Kumar, and those who don't know me, um, I'm a, I am a computer science student. So I started this channel a week ago. So I decided to make a playlist on top 150 interview questions on LeetCode and as well as daily challenges. So it seems in the past week the daily challenges are based on dynamic programming. So I added a new playlist on dynamic programming, so you can refer those videos to get more hands-on dynamic programming approach. So let's dive into today's problem of the day. So the question is a strange printer. There is a strange printer with the following two special operators. The printer can only print a sequence of the same character each time. At each turn, the printer can print a new characters starting from ending at any place and will cover the original existing characters given a string as written the minimum number of turns the printer needed to print it. So the printer has two operations, which is a print a character, a single character, any number of times in a sequence manner, or change the letter or rewrite again in the next step. So, in this example one, the given string is triple A and triple B. Here the operations is with Y because first the printer printed A character three times in a sequence manner, and for the next time the character was changed and it changed it to B, and it prints three characters of B in a sequence. So we get a triple A and triple B in two operations from printing A's and for printing B's. So most of you may think that number of characters are the minimum number of turns, right? So no, that's not the well. It may be applicable for up to some limited test cases. I checked that also. So yeah, let's check it here. So let's go into the example two. You can understand it more clearly. So the given example is ABA. Let's go with the painter once. Yeah. So guys, the example is ABA. To print ABA, it can print. What are the options we have? First, it can print A in first turn. In second turn, it character change it to B, and it can print in second turn B, and in by changing again to A, you can print a 3, right? So the total turns to print ABA is a 3 when first turn it prints A, and at second turn it changes to B, and at third turn it changes to A, right? Again. So let's make it here. So, is there any approach with where we can get less than three turns? Yes, there is one. So, in first turn, let's say, wait a minute, just a minute. So, let's say, just the size of it. So, in first turn, we print it three A's. What we can do in second term, you can start from any starting index, so we can overwrite the existing character, right? So here A can be overwrite with a new character B, and further A can be taken, right? So A can be, which is the existing A, So in two turns we get the resultant string, right? So for any string s, I mean to say, the possible solution, one of the possible solution would be number of characters in it. I mean number of unique characters, right? So if the string is ABC, what are all the turns we get? Minimum turns. In first, it can print triple A's, and by second turn, by overwriting A with B, you can get a string like ABA, and in third turn, sorry, not this one, by replacing third A with C, we can get ABC, right? So this is one approach, or by first return it can take A and directly it can change the character to B and then to C. The number of changes of characters is one of the answer, and for this the answer is 3, which is we can say length of the string or number of unique characters in it, right? So those two answers can be considered for some test cases. So let's go with our solution approach. Okay, guys, now let's see these examples. So here, the printer firstly prints first three. Let me change the color to red. So he prints first turn triple A's, and in the second turn he prints triple B's, right? So number of turns would be 2. So in this, instead of, I mean, for every consecutive duplicates, it would be a single turn, right? So to reduce the string iterations, you can reduce the string 2 by removing the duplicates. So triple S can be shortlisted to single A, and a triple piece can be written to a single B. So now what are the minimum turns does the printer take to print AB? 2, right? Initially it can print A, and at second turn it change letter to B, or initially it can print two A's and in the second turn it can change it to B. So there are or two operations. This mean the solution is same, but instead of iterating over the entire array, I mean entire string, we can do better. So first, what we can do in I mean, uh, first our operation is remove string duplications, right? We can remove them. So our first step would be by removing string duplications. So now let's take another example, which we will make up with logic. So let's take string with a comma b comma c and a comma b comma c. So first we find the minimum steps to print ABC ABC, right? So what we can do, how we solve this one? So initially, uh, let's say we can print initially a 6 years, right? So we solve. Sorry about the handwriting, guys. Please understand this. So at second turn, we can change one B here. So in third turn, it goes for C, and in a fourth turn, we change B. So in fifth turn, we change this C, right? So here C, C, B, B. So in a single turn, we cannot change these two B's at a time. Why? Because the number of B's can be repeat in a sequence manner, not in a randomly, right? So to print a same character randomly, it takes the number of times we are printing that character. So to understand this, and first we come up with the logic. So what we can do? So we take two pointers from, which means by starting and ending pointers. Let's say starting we are at A, and for ending we are at the last position. So we make a function call which finds minimum terms from starting to end in a string, right? So let's call the function. Okay, guys, I just modified this. So we have a string and we make two pointers S and D starting and ending. We make a function call which is minimum terms which returns an integer from a starting index to ending index from string. Yes. So how do we find? So now let's take a pointer k which shows this one. So firstly we find a character from starting to ending which has the, I mean, we find the second occurrences of starting character in the range of starting to end. So here's the starting character is A, right? So A, is there any A from start plus one to the ending? Yes, there is one A, right? So we divide the string into where K will be the character index where A is equal to A, right? So now we find a minimum term for the string, sorry, for the string from starting to k minus 1 and from k plus 1 to ending. So it means we are dividing a string into substrings, and so let's say for we know that for ABC the minimum terms would be 3, right? And for BC it would be 2. And by adding these two, we store the result in minimum terms for starting index S2E, right? So for every starting, what are all the, I mean, values that are valid for starting index? The starting index can be 0 to n minus 1, right? So for any starting index, the ending index also can be from 0 to, the values for end also can be 0 to n minus 1, right? So we store this five variable, I mean five value in a 2D array with the indexes of starting and ending. We store five. And now let's repeat this problem with more examples. So okay, guys. So initially we are at starting index 0 and ending index would be 5, and we called a function, right? So what it do? First, it checks that whether starting index or and ending index are valid or not. So The first condition would be if a starting index is greater than n, we return 0, right? So there is no string which is in this scope, right? So we return 0. So the first condition would be, let's say, first condition, and we write the condition. Let me increment the size. If start is greater than n, what we do? We return 0 for minimum of starting to index. That's the first turn. Let's check 0 is greater than 5. It's not true, right? So we go to the next step. And if the, let's say we need a 2D array, right? So let's say DP array of size n by n. So first index shows the starting value and this shows the ending value. So if DP array of the index 0 to 5, if it is already calculated, I mean already it default contains zeros, right? So if it is already calculated, so we return simply, we return that value, return dp of starting comma ending, right? So that's the one condition for in our approach. Let's put it there. So now what we do, we need to find the same character from starting to, from which starts from start to end, and whenever the starting character is equal to the kth character, we find a subproblem, right? I mean, we take the substring from start plus one, start plus one to k, k minus one, right? So, and from k plus one to ending, we make both function calls for this substring and for this substring. And by adding these, what we will do, we will store in a DP array of, I mean, DP array of S2E, right? So we will take that. So we update this DP of SE a minimum times, right? So if there are multiple A's, or we may calculate the, it may get subproblems, repeated subproblems. So for that, we take the minimum, right? So when we are updating the value, this value, return value, we will take the we will compare previous value and current calculated, and by then we take the minimum, right? So we, let's take a minimum variable minimum. What is the worst case term for a string? It would be its length, right? So there is a string, let us consider, which is A to Z. What are the number of turns to print A to Z? It would take 26, right? Why? Because for every turn it can print a single character. And first turn it prints A, and for second B, and for third C, and so on. For 26 turns it can print Z, right? So in worst case, let's take the minimum turns for the string would be 26. I mean its length, and by taking this length, and whenever there is a common character with the string, we take, we compare or we minimize the string from minimum to this one, right? We make a function call which returns the number of turns needed from starting to index, and from that we take a minimum. minimum of minimum. After getting the total minimum, we store it in, let's say, sorry, we store this in dp of se, right? We store it in this. So I think you understand this one. Let's get more clarity by coding it up. So go. So just say, so what is the our first step? We need to build a string which contains a single occurrence for every sequence, right? So let's take a string x, which is initially, let's take s dot min string dot value of s dot character and 0. It means it contains initially the first character of s, and we iterate on int I equal to 1. Let's say for that we use the letter ch in s, and we convert it into character array. So if character is equal to the last character of x, what we do, we can continue, right? We don't append it. We only add it once, right? Else x plus equal to string dot value of character ch. For this for loop, I mean, we reduce the string characters which are valid after reducing also. So, and we need a 2D array which stores the minimum turns from starting to index for every value arrays from 0 to n minus 1, where n will be the our new string size x dot length, right? Optimized string length. So n comma n, and we need a function called which returns minimum turns from x by starting with 0 to n minus 1 index using the dpl. So it returns an integer. So let's define a function public int min turns. So it takes a string s and it has starting index, and it contains ending index, and it contains the values from starting to end minimum terms. So what we are doing here, firstly check, let me remove this one. First check that the starting and ending values or indices are valid or not. So if start is greater than end, it means we have reached or gone beyond the string scope, right? So we just return for that 0. And if our DP, or if we are calculate the substring with the starting and end values already previously, if you are calculated, we just return that DP of starting and ending. Now, in worst case, what will be the minimum turns for a string which starts from start and end, its length, right? So let's take length start. We are including both, right? Start plus end minus 1. So it contains a minimum number of turns default by with the length. Okay, so and or else we could do one thing. So let's take the first character occurrence 1, and we find from start plus 1 to the end number of occurrences, right? And we know a function which finds minimum turns from for s which starts from start plus one and end using DB. So what does it mean? It returns the minimum terms for from start plus one, right? So and for starting index we need a one term, and we need to find a characters which lies between starting and ending index, which are duplicates, I mean, which are equal to the starting character. So we take as k value from start plus 1, k less than or equal to n, k plus plus, and if the character from start is equal to character from k, what we do, we find, I mean, we call a function called turns from S starting index, I mean, yeah, from starting to k minus 1 as n using dt, and we add it up to minimum turns from k plus 1 to n using dp, and we also pass our string s and we store it in a temporary variable 10 equal to minimum. And for every, I mean to say, if you have calculated, we have to update the our minimum, right? So now we update our minimum value with the previously calculated result, and this result we take from minimum. And after ending for loop, what we get a minimum value. Our minimum turns start as TRT from start to end, which is stored in minimum. And at last we return minimum steps. So this could make up pretty much. This handles good. So let's check it once again. Yeah, it accepted, guys. So let me submit it. Here we are checking every possible move from starting to ending index for every character, right? So the complexity will be, I think, answer or it can be. So yeah, previously I used it for the offering 150 interview questions. In that, I have already used it to check the complexity. So we may not find it now. So thanks for watching, guys, and I am also making a playlist on top 150 interview questions, and I have created a new playlist for dynamic programming problems, and I also given the solutions for those problems. Please check it out, and if you like my content, share it to your friends, share this channel, and it could be helpful. And if you have any queries, please let me know in the comments, so I will reply. And if you have any suggestions for me to improve my way of teaching or explaining, and I can do it in a better way. So thanks once again. So you can follow me on Twitter also. So you can ask me any questions related to it. So see you in the next lecture.